the last video we established that we had a running EP5, right? I put the side plates on that low hour New Haven that had broken pilots. And then I stuck the transformer on this one and realized it was a runner too. I just had to turn off the switch for cruise control. And in that video, I also talked about the concept of doing something outdoors. Kind of like having a group of guys come together and have a shovel or a hoe, you know, stretch a track and some food and a locomotive, and let's go build a railroad from one spot to another outside up there on the hill. And I'm going to explore that a little bit. And one of the things I've got up there is I have these electric fence chargers, and they run off a battery, car battery, and that battery is charged with a solar panel. Of course, they run continuous, and they don't have the same kind of amperage draw that a transformer does, right? You know, you figure we're talking a few amps, say 1.5 to 2 amps per locomotive at a minimum, right? And the fence chargers don't have anything near that, I don't believe. So here's the premise. How long can I run a train from a charged battery through, you know, just a basic inverter? So what I want to do right now is just prove the concept that I can actually turn on a transformer off a battery through an inverter and make that thing go. And then if that works, which of course it should, the next step is to put that battery in the train room, connect it to that, to one of the tracks, and see if I can run a train, see if it has enough oomph to do that. And then after that, of course, hook up the same solar panel that I have for the fencer to the said battery that came off the fencer, and see whether or not I can get like a half-hour runtime off the battery and then let it go and then have it spend the day charging it back up. Concept being, you know, let's say I want to run it off the battery in the evening. It charges all day long. Then I run it for a little bit, and it may take a day or two before I get back to running it again. And hopefully the solar charger has brought the battery back up to, you know, snuff to where I can run it for a period of time. And of course, the bigger concept is if I want to run an outdoor railroad up on the hill where there's no power, instead of using a little dinky battery like that, I'll probably go get a pair of inline 6-volt batteries I use for my big International. I've got a couple of those spares, and they hold a tremendous amount of power and amperage. I mean, they're have enough amperage capability to fire off a big diesel, so they should be able to run a train for a period of time. And then again, augment the charging with a solar panel and kind of move this into another phase where instead of drawing off the grid all the time, maybe we can have a solar powered model train. How's that? And again, this is all driven by the idea of doing, you know, train type get-togethers where the guys are a little bit more adventuresome than the typical hide in the basement type, and get outside and build a track, go climb up a hill, make a couple of switchbacks, whatever we got to do, and see if we can get a train to go up that carrying a hot dog or something like that is the definition of win. But do it outside. You know, everyone bring enough track to matter and elbow grease and sense of adventure, and I can supply, you know, batteries from the fence chargers and stuff and enough solar panel to charge them up rather quickly. See if we can't have a little bit of fun with that concept, you know. So here's what I'm going to do for this video is first just test a theory and see if I can run this EP5 through the Lionel transformer, and if it works, I'll go see if I can run the track, you know, for a period of time with a train on it. See what happens. Okay, so this here would normally go to the solar charging system. I don't have it right now because it's night, right? And these two leads go to an inverter. And I've got the Lionel transformer plugged in. So let's turn it on and see if we have enough voltage to do anything. It says there's 12.9 volts and it's almost 100%. And I'm getting a good hum right there. Now, the reality is that this was the battery on the fence charger, and in fact it was charged with a solar panel. Let's see if we can make this thing go. All right, it works. So now let's go run a train. Okay, it's on, and here's the wire. It's plugged into the inverter, which is tied to the battery. So let's see if we can get some train time on this. Well, based on the amperage draw, which is negligible, I could probably run that for quite some time. And I'm not seeing any change. Well, it went from 12.8 to 12.2 volts. So over the last few minutes, it's dropped a little bit. I'm going to go run something that has a lot more amperage draw and see if I can draw this down further. Point being, if I've got solar panels on this, does that give me an acceptable train run time? Of course, I've got no panel on it right now. I'll show you the panel we're going to attach, but right now I've got nothing. But I will put the Lionels on there, which will draw quite a bit more amperage, and maybe draw this thing down a little quicker. Well, let's up the amperage draw a little more than that. Check that thing out, man. That pulls all those cars. That's, well, including the tender. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cars by that little thing right there. I think that's the locomotive I'm going to use outdoors. That one right there. Well, still hasn't dipped below 12 volts. It's like 12.2 right now, according to the voltmeter on the inverter. So let's go and try to draw a little more with one of my Alco's, either a powered A combination or a powered A, powered B combination. See what happens. But the point so far is that I could actually run a train outdoors with this thing. So that whole idea now is possible. And again, how I charge that battery doesn't really matter. Just as long as when it's charged up, I get enough runtime to be interesting. And I think we've proven that's already the case. So let's put some more time on there. Okay, this one is a powered A, powered B. You can see where I roughed that together. This was the very first one that I ever did. Now, it's going to have probably 2.5 amps as a draw. Well, I let it run for a few minutes, and it's still at 12.1 volts, the battery is, which means there's a fair amount of amperage hours left. So let me up the scale a little bit. I'm going to change the train out and put a larger train on there. You know, an old scale train like a Williams or something. But when I do outdoor stuff, it'll be one of these alcos probably. They're pretty much indestructible. So anyway. Well, I had my first train wreck there. The caboose didn't fit underneath the Lionel Bridge and pulled the cars off the track and crashed them into my forest. So we're still at, well, it says 12.4 volts now in the battery. So let's start this again. But I think the point's been made here. Oh, we got some that are still off. See if I can get them around with big horsepower. Oh yeah, look at that. This is one of those no replacement for displacement moments. Alright, let's put them back on. And see if I can get this train back on track. No pun intended. Well, pun intended, but... Alright, so I have everything on. All right, so the answer is yes. See where we are in voltage. It still says 12.3 volts. So, yeah, my guess is you'll probably get roughly 4 or 5 times the time that I have on this video in terms of a runtime, which means, I don't know, maybe half hour, 40 minutes. And I was able to run both tracks. My camera's driving me nuts. Watch this. As I go in and out, it decides which zoom lens to use. It has 5 different lenses. Changed. See it change? Now I don't have any control of that. Changed again. See that? Long distance. See it change? Huh, no control of that. But what I do control is the fact that this transformer can be powered by either this inverter tied to a battery or back to the power bar. That's what I do have control of. And what I'll do now is put them back on the power bar so I can run them the way I want. And I'll put the solar panel on the battery, and then tomorrow let it charge, and then tomorrow evening I'll put some runtime on it. But I think we've proven the point. Works just fine. And that's a standard inverter you can get for about $70 at Harbor Freight. And these, of course, are the K-line Power Chief transformers. And there's 3 vertical can motors in that outfit right there. 1 in the lead locomotive and 2 in that one. No problem. I don't know, maybe I'll put together yet another train. A little bit different. And give it a little more runtime. So this is the actual panel that was used to charge that battery up in the field. Still has a bunch of hay on it. So what I'm going to do is mount this up in the window and let it charge that battery all day, and then we'll run it at least one track with the battery and inverter alone. I'll separate it out from the other stuff so I can run the lights and all that with house power. And then next time the power is out, I got this system right here where I can play trains this winter. But I think that's really cool. So, Marine battery, Coleman brand panel and charger, solar panel and charger. K-line Power Chief worked just fine. And then all the locomotives I put on this thing so far have had no problem. And that's from vertical cans to Lionel Pulmores. I think that's a video right there. But that proves the point. We can do this out in the field if we want to. The outdoor concept is developed a little more. Yeah, it looks like he's going in the north side of the yard. So I heard him, the defect detectors calling him heading east on track 2. And then somewhere around 290, milepost 290, he moved over to track 1. And then now he's heading into the north side. I don't know what track that would be. Track 7 maybe? But look at all those spine cars. You know, I've got one in the mail.